Okay, so this was a little test that you had on logs. So you can see the first question there. Just move this around for myself. So you've got log to the base 4 of 6x plus 1 take 2 is equal to, and you've got your 2 on front. So there's a couple of things to notice with this. First of all the bases are the same, so that's always a good thing. That means that after a little bit of tidying we might be able to cancel the logs off or something like that. This 2 on front, I'm going to take it and it's going to jump up there straight away. So I'm going to do that. So log 4 of 6x plus 1 take 2 is equal to log 4 of x squared. Next step, I'm going to bring all the logs maybe to one side, because then I'll be able to use some rules. So I'm going to have log 4 6x plus 1 minus, so this portion of it here will become a negative, so minus log 4 of x squared, and at the same time I'm going to add 2 to both sides. So now I'm going to use my law of logs here. When I'm subtracting in logs, it means I can rewrite it with just a single log and base, and I can manipulate the two parts, the two variables here. So log 4 6x plus 1 over x squared equals to 2. Now, using my first law of logs, I can take that base and it'll give that 2 a little kick. So we've seen this done in class. So 6x plus 1 over x squared is equal to 4 to the power of 2. I'm going to create a little bit of space for myself. You'll end up with 6x plus 1 is equal to 16x squared. 0 is equal to 16x squared take 6x take 1. You're going to factorize that. We have 8x and 2x. You'll need a plus 1 and a minus 1. Solving those out, you'll end up with 8 is equal to minus 1 over 8. Sorry, x is equal to minus 1 over 8, and x is equal to a half. Of course, you can't get the log of a negative number. We're not rejecting this answer because it's negative. We're rejecting it because when minus 1 over 8 gets put in here, I can't get the log of a negative number. So we reject. So that was the first part. You might have been able to do it a couple of different ways, but it's a nice way to revise some of the rules. Okay, so the next part of the question says that given that p is equal to log to the base e, so just a quick reminder, if you could write p as ln x. I'm not going to do it. Just a little reminder that if you sometimes when students see ln x, they get a little bit flustered by it. You might prefer to change it back into log to the base e of whatever the variable is, just until you get a little bit more comfortable with natural logs. So we've got this portion here that we have to try and play around with. So I'm going to just write it here. So I've got log to the base e root x plus log to the base e of cx. So first thing I'm going to do, I'm going to use one of my rules of indices, that root x there. That being to the root of x means it's to the power of a half, so log e x to a half plus, and this bit here, this c and x, well they're being multiplied, so I can reverse one of my rules of logs and I can say log e of c plus log e of x. So things are starting to come together for me because I want to see lots of log ex's. So this half is going to take a little jump down here, so this will be a half log ex plus log ec plus log ex. Of course this bit is just a p, this one is a half of p, and this one here, log to the base e of c. You can leave it as log to the base e of c, I have no problem with that. You could just change it to a k, it's a constant. Adding the p's, adding like terms, so 3 over 2p plus k. Okay, so that was the second question. I'll come back to the third question in a moment. That question involves change of bases, so I'm not going to do that right now. I'll do that at the end. So, question number 4 says, by letting y equal to 2 to the x, solve this equation. So there's a little bit going on. There's a little bit, I suppose, of manipulation that has to be done with this before you can do anything. So I'm happy with the minus 3 to the 2x. I'm not going to do anything there. I'm happy with the 2. Little note, you can't multiply the 3 by the 2 to give 6 because the power here is stopping you. Okay, so that's sometimes a common little mistake that people make. I'm just going to go over here to the side. I'm going to say 4 to the x. I'm going to say 4 is the same as 2 to the 2, and that's to the x. And of course, I can just swap that. That means I can write this in 2 different ways, and depending on the question that you have, that will dictate how you do it. So for example, I could leave it, power to a power means multiply, so I could say 2 to the power of 2x. That would be no problem. But I want a 2 to the x on its own, so I could also say that that's 2 to the x to the 2. So I'm just swapping the 2 of these. So I'm going to take that and I'm going to put it in here. So I've got 2 to the x all to the power of 2 minus 3 2 to the x plus 2 equals to 0. Now I'm going to use my substitution because it'll make it a little bit easier for me. So wherever I see a 2 to the x, I'm going to put in a y. So y squared minus 3y plus 2 is equal to 0. I'm going to solve that out via factorization. So y, I need a 2 and a 1. I need a minus and a minus. So I'll get y is equal to 2 or y is equal to 1. Now very often people stop at this point, and they forget that they have made a substitution, so they have to reverse that substitution. So 2 to the x equals to 2 to the 1. 2 to the x is equal to 1. So here we say x is equal to 1. Here we say 2 to the power of what will always give me 1. X would have to be 0. Okay. 5th question. Answered quite well in the test, to be fair. Solve for x, an element of r. 5 to the power of x is equal to 127.5, and it's 3 decimal places. So I'm just going to write this out again. So I've got 5 to the x is equal to 127.5. Basically what the logs are great for is they allow me to access powers. So what I'm going to do is I'm going to get the log of both sides. But I'm going to be quite picky about the log that I pick. I'm going to pick log to the base 5, and then this 5x will pop in here. And I'm going to do what I do to one side, I have to do to the other. So using my rules of logs that we saw earlier, that will pop down. So now I've got x times log 5 is equal to log 5 127.5. And of course, why was I choosy about the base that I wanted? Well, because anything, whenever the base is the same as whenever these two numbers match, you'll just get 1. So that really means x times 1 is equal to log 5 127.5. Into your calculator, 3 decimal places, 3.012. Okay, so just to finish up, let's leave that there for a quick second, or you can pause it. Just to finish up, I want to talk to you about question 3. So some classes have done this before, it's a change of base, some classes haven't. So this is the question that you were asked in the test. It says, solve log to the base 9, x minus 2, blah blah blah. The important thing to notice here is the bases are different. Now because the bases are different, that stops me using any of my rules of logs. Right? That's the basis of any of the rules or any of the laws of logs. So I'm going to show you a quick rule. It is one of the laws of logs, and it goes like so. If you have log to the base a of b, Well, what you can do is you can change that to log. Now, you can put in any base that you want. I'm going to choose C. So you'll notice C is a new base. It's not the same as this one over here. But the thing to remember is the B is slightly above the A. So the B goes on top, the A goes to the bottom. So this will be B and A. So the exam question, or the question in the test, we'll use this law now in just a moment, says log 9 x plus 2 minus log 3 x equals to 0. So I'm going to choose to use this law of logs on log to the base 9. And the way I choose what base I want it to be is in order to use the other rules that I have, I need it to be the same base as this one. So I'm going to say log 3 over log 3. X plus 2 is on top, and the 9 is on the bottom. This, of course, here can be just evaluated on a calculator. And you'll end up with 2. So you'll have log 3 x plus 2 all over 2 minus log 3 x equals to 0. I'm going to multiply everything across by 2. So log 3 x plus 2 minus 2 log 3x equals to 0. I'm going to move this 2 in here. And just for convenience, I'm going to take this portion and I'm actually going to bring it over to the right hand side. And once I've got a log equals to a log, it allows me to cancel them off. So I'm just left with x plus 2 is equal to x squared, and you'll work that down. I'm going to just say to you that x is equal to negative 1, x is equal to 2. Of course, we'll reject this. Not because it's negative. We don't reject it just because it's negative. We reject it because when it's put back into the original back up here, we would have to try and evaluate log to the base 3 of negative 1, which can't be done. So that's your change of base rule.